The history of powerful telescopes is a tale of human ingenuity, scientific advancement, and the quest to understand the cosmos. From the rudimentary instruments of the early 17th century to the sophisticated observatories of the 21st century, telescopes have revolutionized our knowledge of the universe. The journey of these instruments reflects the broader progress of astronomy and the relentless pursuit of ever greater clarity and detail in our observations of the heavens. The story begins in the early 1600s with the invention of the telescope. Although the exact origins are somewhat disputed, the earliest recorded use of a telescope for astronomical purposes was by Galileo Galilei in 1609. Galileo's improvements to the early Dutch designs allowed him to make groundbreaking discoveries, including the moons of Jupiter, the phases of Venus, and the detailed observation of the lunar surface. His use of the telescope fundamentally changed our understanding of the universe and laid the groundwork for future advancements. As the 17th century progressed, telescopic technology continued to evolve. Johannes Kepler proposed a new type of telescope in 1611, known as the Keplerian telescope, which used a convex lens as the eyepiece and improved image quality over Galileo's design. This innovation paved the way for further developments in optical astronomy. The 18th century saw significant improvements in telescope design, largely due to the efforts of figures like Isaac Newton and William Herschel. Newton's introduction of the reflecting telescope in 1671 was a major breakthrough. Unlike refracting telescopes, which used lenses to gather and focus light, reflecting telescopes used mirrors. Newton's design minimized chromatic aberration, a problem in refracting telescopes where different colors of light do not converge at the same point, leading to blurred images. This innovation allowed for much larger telescopes to be built and was a crucial step in the development of modern astronomical instruments. William Herschel, a prominent astronomer of the 18th century, made significant contributions to telescope technology and astronomy. In 1781, Herschel discovered the planet Uranus, and he credited much of his success to the large, 40-foot reflecting telescope he built himself. Herschel's telescope was the largest in the world at the time and demonstrated the power of large mirrors in capturing faint celestial objects. His work established the importance of large, well-designed telescopes for advancing astronomical research. The 19th century witnessed even more remarkable advancements. The advent of glass-making technology allowed for the production of larger and more precise lenses. This period saw the construction of several significant telescopes, including those at major observatories. In the United States, the Yerkes Observatory, established in 1897, housed the largest refracting telescope of its time. Its 40-inch, 1.02 meters, diameter lens was a marvel of engineering and optical design. The Yerkes telescope was used for numerous astronomical discoveries and remained the largest of its kind for many decades. The early 20th century brought further innovations with the advent of the 100-inch, 2.54 meters, Hooker telescope at the Mount Wilson Observatory in California. Completed in 1917, the Hooker telescope was the largest optical telescope in the world at the time and played a crucial role in expanding our understanding of the universe. Edwin Hubble used this telescope to provide evidence for the expanding universe theory, leading to the formulation of Hubble's law and fundamentally changing the field of cosmology. The mid-20th century saw the development of even larger telescopes and the introduction of new technologies. The Palomar Observatory, with its 200-inch, 5.08 meters, Hale telescope, was completed in 1948 and became the largest optical telescope in the world. The Hale telescope was instrumental in many important discoveries, including the determination of the size of the Milky Way galaxy and the discovery of quasars. The latter half of the 20th century and the early 21st century have been marked by the development of space-based telescopes and advanced ground-based observatories. The launch of the Hubble Space Telescope in 1990 represented a monumental leap forward. Positioned above the Earth's atmosphere, Hubble was free from the distortions caused by atmospheric interference and provided incredibly detailed images of distant galaxies, nebulae, and other celestial phenomena. Its observations have been crucial in determining the rate of expansion of the universe, studying dark matter and dark energy, and exploring the formation of stars and planetary systems. In addition to Hubble, the late 20th and early 21st centuries have seen the development of other space-based observatories like the Chandra X-ray Observatory and the James Webb Space Telescope, JWST. Launched in December 2021, JWST is designed to observe the universe in the infrared spectrum, allowing scientists to peer through cosmic dust and observe the earliest galaxies formed after the Big Bang. Its large primary mirror and advanced instruments are expected to provide unprecedented insights into the formation of stars, galaxies, and planetary systems. Ground-based observatories have also continued to advance. The introduction of adaptive optics in the 1990s allowed ground-based telescopes to correct for atmospheric distortions in real time, significantly improving the quality of astronomical images.